Welcome all. In this video, I shall be discussing about simulation of pi using Monte Carlo method, and this will be implemented using Python. Okay, in order to find out the value of pi, we will consider the area bounded by quarter of a circle. Okay, let us consider a circle of radius r. You know that its area is equal to pi r square. Now if r is equal to 1, then this area will be pi into 1 square, that is just pi. Okay, now let us consider a quarter of a circle defined like this. Consider xy axis, x axis and y axis. Let us consider a quarter of a circle like this of radius 1. Obviously the circle, remaining part of the circle will be something like this. Okay, so this is the required sector. So this side is obviously 1 and this side is also obviously 1. Now in order to find out this area, let me call that area as A. I consider a simple area which contains the area of interest small a, correct? So that will be obviously a square whose area is obviously 1 into 1, that is 1. Okay, now I know that pi by 4 is nothing but a, therefore pi is equal to 4 into a. Now how can I calculate this small a? So that is a problem. For that let me construct another arc. Okay, a sector, then with a simple area like this. The side is 1 unit, this side is also 1 unit, this side is obviously 1 unit, this side is obviously 1 unit. So this is the case. Now I just randomly select some points, some xy points. So I choose random xy points where the value of x is in between 1 and the value of y is also in between 1 and 0. So we choose randomly numbers to represent xy pairs. So let me tabulate the x and y values. X, y. So initially I choose x is equal to 0.1 and y is equal to 0.3. Okay, now I can calculate the distance. Say, let me calculate the square of the distance. So that is d square, which is nothing but x square plus y square. Now I calculate the distance square. So here it is 0.1 square plus 0.1 square plus 0.3 square, which is equal to 0.1 square is 0.01 and 0.09. So squaring and adding, you will get it as 0.10. So the distance square is 0.10. That means I considered a point somewhere here, which is 0.1 and 0.3. Now I have calculated the square of the distance from the origin and I found that it is 0.1. Okay, I went wrong. Point. Okay. Okay. So point 1, which is so we can say that this point will be obviously inside the area of interest, because if the distance square is more than 1, or if the distance itself is more than 1, it will be outside the area of interest, and if it is less than or equal to 0.1, sorry, less than or equal to 1, we can conclude that it is inside the area of interest. So I consider this as a point inside. So this way I generally consider a point x, then y, then I calculate the distance square d square, and I check whether this is less than 1. So if d square, that is, I can say that x square plus y square is less than or equal to 1, I just count it to 1. So that means I just increment the n value to n plus 1. So I increment that by 1. And if this condition fails, I just ignore that point. So this way I consider n, that is very large number of, sufficiently large number of random xy points. I count how many of them falls in the area of interest. That means n is the number of points inside our area of interest. Correct? Therefore, if that is the case, I can write a by capital A will be equal to n by capital N. Therefore, my area of interest is small n by capital N into A, which is just small n by capital N into 1, that is small n by capital N. Therefore, I can calculate pi as, from this formula, pi is equal to 4, no? So pi is equal to 4 star n by n. So this is my formula. So this is the idea behind simulating the value of pi. Okay. Now let us consider the algorithm. It's really simple. We have to generate random numbers. Therefore, we have to import numpy. So the first step is to import numpy as np. Now we have to set some capital N value as 1. Sorry, as some 1000. Say we will choose a large number. Then we will initialize small n as 0. There are no points. Now we have to iteratively, or we have to randomly select x points and y points. So we will just consider x points as a list. X points is equal to the np dot random n. So we'll generate n random points. Similarly, we generate y points as np.random.random. Obviously, these are, since they are random numbers, x points and y points will be different. Now what we have to do is we have to choose ith value from x points and ith value from y points, and we have to check whether that is inside or outside the area of interest, whether that point is inside or outside the area of interest. If it is inside, increment n by small n by n plus 1. So what we have to do is, we have to start a for loop for I in range n. So we have to repeat that n times. What we have to choose is, we have to choose xy points. So first we will consider the ith value of x points, then we square it, then we add that with the y value, so y points of I. Okay, so that is the distance. And if this quantity is less than or equal to 1, what we do is we just increment n by n plus 1. So this is the only step. Fine. So with this, once the loop is over, okay, so you please note that this if statement is within this loop. So once the loop is over, our n is calculated. Now it's very simple to calculate pi. You just calculate pi equal to 4 star n divided by capital N. So this is the y value. You can print pi equals comma pi. So this is very simple. Next step, you can see this result by plotting everything, plotting every points as dots and plotting a circle in between. So that will be discussed when we do the Python code. So the algorithm is really simple. We just import all the modules. So we initialize. The first step is to import modules. If you need to plot, you have to import both NumPy and Matplotlib. Then initialize small n and capital N. Then generate n random x points and y points. Then count number of points which is inside the sector of the circle. Then calculate pi as 4 into small n by capital N. Then print pi. So these are the steps involved. So this is the code for the algorithm. So all the steps are understood, self-explanatory. This is the maximum number of random points we are going to generate, and this will obviously generate n such x coordinates, and this will generate n y coordinates, and this will check the given xy point, ith point, we can call it the ith point. We check ith point is inside, check whether the ith point is inside. So if this condition is satisfied, it is inside, then we increment the count. And this is the formula, direct formula to calculate pi, value of pi, and we just print the result, we just display the result. So this is very straightforward and very simple. Okay, now let's run the code. Okay, I'm going to run the module. Okay, you can see the value of pi as 3.15, but this will not be the same if I run the same code without changing capital N. You can see that it is 3.1232 because we are generating random points. We'll get different answers when we execute several times. Okay, you can see that now it is 3.14, but increasing the number will help us. So let me increase that to very large number so that you can see the result will be, it will take little bit time, but it is 3.14. You can just trust the result. Okay, 3.139, again 3.14. So making the number large will give you better result, because as we have already explained, this method, Monte Carlo method, basically works on the principle of law of large numbers. All right. So the steps from this line to this line is already explained. This is to show the plot something like this. Okay, so we have to import matplotlib. So this is basically to create a square plot, and this we set the limits of axis, limits of both axes. So this is the x lower limit, x lower limit is 0, y lower limit is 1, x maximum limit is 1, y lower limit is 0, x upper limit is 1. Then we just plot all those points. We have selected n random points. So the x coordinate of them is in x point and the other is in y point. We just scatter plot them. So you can see the distribution. This is not uniformly distributed. We have randomly distributed. For example, you can see that in this region, let me mark some region. So you can see that in this region there is no point at all. Okay. So if you consider the similar area somewhere here, there will be some points. Okay. So you can see that this is not uniform distribution. Okay, so we randomly distribute the points and we just count how many of them are inside and how many of them are outside. So that much is very straightforward. Now you can see this circle. I have just plotted a red circle, not circle, complete circle, a quarter of the circle. So in order to plot that circle, I am using the next lines. So we know that this quarter of a circle, the angle, if you consider the angle, it will be from 0 degree to 90 degree, correct? So 90 degrees pi by 2 radian. So we have generated such 100 points between 0 to 90 degree or 0 to pi by 2. Now we know that if you consider any point on the circle, if you consider any point on a circle xy, then x by r is equal to cos theta, or x is equal to r cos theta. So in this case our r is just 1, therefore our x coordinate is just cos theta. Similarly you can you can calculate y as y is equal to just sin theta. So I have just calculated the xy points, such 100 points. Okay, 100 points on this arc, correct? So for that equally spaced 100 points I have generated the I have to generate such 100 points. So I just call x is equal to np cos theta and y is equal to np sin theta. right? So this will create the xy coordinates of the circle, and I just plotted that, and then I have used this show function. Okay, we'll see the execution in the next slide. Okay, now let us see the code. I have added several parameters additionally. So in this case, I have to plot the points as well as the sector. So for that I am going to import matplotlib. Then you can see that I have generated some figure with the axis limits are x limits are 0, 1. That means our x-axis extends from x equal to 0 to 1. Also y-axis extends from 0 to 1. Then I just plotted both x and y points, random endpoints. I used scatter plot so that I can see the points. Now I have to generate a particular arc which extends from 0 to 90 degree. So we have just added that code for them. Then we just plotted that. This will be plotted in red color. So let us see the result. So you can see the points are, some points are inside the area of interest while some other points are outside the area of interest. Okay, so we just counted all those points which fall inside the area of interest as well as on this line. Okay, you can see that the result is little bit less. I have used a small number in order to make the figure more clear. So if you if you increase the number, naturally you will get a better result, but you can see that the points get crowded at some points. Okay, so this time however our result is more clear, 3.1332. Okay, thus we have simulated the value of pi, and we have observed that as we choose large number of random points, our result will be in good agreement. The more larger the number, more in agreement with the correct value. Okay, so I request you to try with different numbers, capital N. Thank you.